Assalamualaikum and a
and a
very good
very good
evening to
evening
all
to all
the
the
participants
participants
that
that
have
have
joined
joined
tonight.
tonight.
So we
So
are
we are
from
from
civil engineering student under the subject of civil
civil
engineering
engineering
material.
student under the
Today we
subject
would
of
like
civil engineering
to
material.
present to you guys
Today we would like to
about
present to you guys about
concrete problem occur in
concrete problem
your
occur in
building.
your building.
So
So
we have
we
shared to
have shared to
you
you
the
the
Google
Google
thing
thing
or
or
Google
Google
form
form
so
so
we
we
can
can
investigate
investigate
the
the problem
concrete
concrete
problem
problem
in
in
your
your
building.
building.
So
So
before we
before we
start,
start,
I would
I
like
would like
to
to
continue
continue
with
with
the
the
concrete.
concrete.
So,
So,
what is
what is
concrete?
concrete?
Concrete
Concrete
is
is
an
an
artificial
artificial
stone,
stone
like a
like a
mass.
mass.
Is the
Is the
composite
composite
material that
material
is
that is
created
created
by
by
mixing the
mixing the
binding
binding
material,
material,
such
such
as
as
cement
cement
or
or
lime,
lime,
along with
along
the
with the
aggregate.
aggregate.
For
For
example,
example,
sand,
sand,
gravel,
gravel,
stone,
stone,
bricks,
bricks,
and
and
chips,
chips,
with
with
water
water
admixtures
admixtures
in
in
specific
specific
proportion.
proportion.
The
The
strength and
strength and
quality
quality
are
are
dependent
dependent
on
on
the
the
mixing
mixing
proportion.
proportion.
Concrete is
Concrete
a
is a
very
very
necessary
necessary
and
and
useful
useful
material
material
for
for
construction work.
construction work.
Once all
Once
the
all the
ingredients,
ingredients,
which
which
are
are
cement,
cement,
aggregate,
aggregate,
and
and
water
water
unit
unit
of
of
measurement
measurement
meets
meets
inside the
inside the
required
required
proportion,
proportion,
the
the
cement
cement
and
and
water
water
begin a
begin a
reaction
reaction
with
with
one
one
another
another
to
to
bind
bind
themselves
themselves
into
into
a
a
hardened
hardened
mass.
mass.
This
This
hardened
hardened
is the
is the
rock,
rock
like a
like a
mass
mass
is
is
the
the
which
which
is
is
concrete.
concrete.
Concrete is
Concrete
so
is so
powerful,
powerful,
easy to
easy to
create,
create,
and
and
could be
could be
formed
formed
into
into
varied
varied
shapes and
shapes and
size.
size.
Besides that,
Beside that,
it
it
is
is
reasonable
reasonable
low
low
cost
cost
and
and
is
is
instantly
instantly
mixed.
mixed.
It is
It is
designed to
designed to
allow
allow
reliable
reliable
and high
and high
quality
quality
fast track
fast track
construction.
construction.
Structures
Structures
designed
designed
with the
with the
concrete
concrete
unit
unit
of
of
measurement
measurement
plenty
plenty
durable
durable
and
and
should be
should be
designed
designed
to
to
face
face
up
up
to
to
earthquakes,
earthquakes,
hur-
hur-
hurricanes,
hurricanes,
typhoons,
typhoons,
and
and
tornadoes.
tornadoes.
This is
This
an
is an
incredible
incredible
advancement.
advancement.
With all
With all
the
the
scientific
scientific
advances
advances
they are
they are
in this
in
world,
this world,
there still
there
has
still
not
has
been
not
a
been
way
a way
of
of
preventing
preventing
nature's
nature's
injury.
injury.
So next slide.
Next slide.
Next,
Next,
this
this
slide
slide
show
show
you
you
the
the
composition
composition
of
of
basic
basic
concrete
concrete
mix.
mix.
So there
So
are
there are
four
four
basic
basic
ingredients
ingredients
within the
within the
concrete
concrete
mix.
mix.
First,
First,
body
body
material like
material
a
like a
cement or
cement or
lime,
lime,
aggregates
aggregates
or
or
inert
inert
material
material
such
such
as
as
fine
fine
aggregate,
aggregate,
for
for
example, is
example, is
sand,
sand,
coarse
coarse
aggregate,
aggregate,
which is
which is
stone,
stone,
chips,
chips,
bricks, and
bricks, and
chips.
chips.
Next is
Next
a
is a
water,
water,
and the last
and the
one
last
is
one is
admixtures.
admixtures.
The
The
example for
example for
admixtures is
admixtures is
pozzolana.
pozzolana.
So
So
first,
first,
what is
what is
binding
binding
material?
material?
Binding
Binding
material is the
material is
main
the main
element of
element
a
of a
concrete
concrete
mix.
mix.
Cement is the
Cement is
most
the most
commonly
commonly
used
used
binding
binding
material.
material.
Lime could
Lime could
also be
also be
used.
used.
When water
When
is
water is
mixed with the
mixed with the
cement,
cement,
a
a
paste
paste
is
is
created
created
that
that
coats
coats
the
the
aggregate
aggregate
within the
within the
mix.
mix.
The paste
The paste
hardens
hardens
and the
and the
bind
bind
the
the
aggregate,
aggregate,
and
and
it will
it will
form
form
a
a
stone
stone
like
like
a
a
substance.
substance.
Next one
Next one
is
is
aggregates.
aggregates.
Sand
Sand
is a
is a
fine
fine
mixture.
mixture.
So
So
gravel or
gravel or
crushed
crushed
stone
stone
is the
is the
coarse
coarse
mixture
mixture
in
in
most
most
mix.
mix.
So
So
what is
what is
aggregate?
aggregate?
Next one
Next
is
one is
water.
water.
Water is
Water is
required to
required to
with
with
chemical
chemical
react
react
with the
with the
cement.
cement.
Uh,
And
the
the
process is
process is
called
called
hydration.
hydration
To
to
supply
supply
workability with
workability
the
with the
concrete,
concrete.
the
The
number
number
the
the
number of
number of
water
water
within the
within the
combined
combined
in
in
pounds
pounds
compared with
compared with
the
the
number of
number of
cement
semen
is
is
named the
named the
water
water
cement
semen
quantitative
quantitative
relation.
relation.
The
The
lower
lower
the
the
water
water
swimming
swimming
quantitative
quantitative
relation,
relation,
the
the
stronger the
stronger the
concrete.
concrete.
Next.
Next.
Next,
Next,
I will
I will
continue
continue
with
with
the
the
bleeding.
bleeding.
So,
So,
what is
what is
bleeding?
bleeding?
Bleeding in
Bleeding in
concrete
concrete
occurs
occurs
when
when
the
the
excess
excess
water
water
comes to
comes
the
to the
surface
surface
of the
of the
concrete
concrete
due to
due to
the
the
settlement of
settlement of
heavier
heavier
components
components
like
like
aggregates
aggregates
and
and
cement.
cement.
Excessive
Excessive
bleeding can
bleeding can
also be
also
a
be a
result
result
of a
of a
weather
weather
condition
condition
because
because
if
if
the
the
evaporation
evaporation
rate
rate
and
and
temperature
temperature
are
are
not
not
in
in
the
the
requisite
requisite
standards,
standards,
then the
then the
water
water
droplets
droplets
will
will
keep
keep
surfacing.
surfacing.
In the
In the
curing
curing
of
of
concrete,
concrete,
bleeding is
bleeding is
general
general
process.
process.
However,
However,
excessive
excessive
bleeding
bleeding
can do
can do
more
more
harm
harm
as
as
it
it
lessens
lessens
the
the
strength of
strength
the
of the
concrete.
concrete.
So,
So,
this slide
this
show
slide show
you
you
the
the
causes
causes
of
of
bleeding
bleeding
in
in
concrete.
concrete.
First,
First,
too much
too much
cement
cement
uses in
uses
the
in the
concrete
concrete
mix.
mix.
Next is
Next
the
is the
too
too
much
much
of
of
a
a
cost
cost
aggregate
aggregate
in
in
the
the
concrete
concrete
mix.
mix.
So,
So,
like I
like I
said
said
before,
before,
cost
cost
aggregate,
aggregate,
for
for
example,
example,
is
is
like
like
stones,
stones,
chip,
chip,
brick,
brick,
and
and
chips.
chips.
So, the
So the
next
next
one
one
is
is
not
not
enough
enough
use
use
of
of
fine
fine
aggregate
aggregate
and
and
excess
excess
water
water
in the
in the
concrete
concrete
mix.
mix.
And the
And the
last
last
one,
one,
amount of
amount of
water
water
is
is
too
too
little
little
in the
in the
concrete
concrete
mix.
mix.
So,
So
this slide
this
show
slide show
you
you
the ways
the
to
ways to
reduce
reduce
bleeding in the
bleeding in the
concrete.
concrete.
First,
First,
strictly
strictly
maintaining
maintaining
water to
water to
cement
cement
ratio,
ratio,
adding
adding
sand
sand
of
of
finer
finer
particles,
particles,
supplementary
supplementary
cementitious
cementitious
material to
material to
increase
increase
water
water
absorption.
absorption.
And the
And
last
the
one,
last one,
adding
adding
air
air
entertaining
entertaining
admixtures.
admixtures.
Segregation is the separation of cement paste and aggregate in concrete. To put it simply, the cement paste runs to the top while the aggregate falls to the bottom of the concrete in this situation. Because good concrete is always an even and homogeneous mixture, segregation has an impact on its durability and strength. The causes of segregation, firstly, is concrete ingredient in an uneven proportion. Concrete mix design specify the exact quantity of water and weight of concrete. Ingredients like aggregate, cement, which are required to make concrete. At the time of concrete mixing, if the ingredients of concrete are not mixed in proportions in concrete mix design, it results poor workability of concrete. Poor workability of concrete may be the cause of segregation. Secondly, is the insufficient mixing time of concrete. During the mixing of concrete at the site, many times concrete workers do not mix an ingredient in a proper manner. Sometimes concrete is mixed for the lower duration or for longer duration. In both cases, the aggregate may separate from the mix and it may be the reason of the segregation. Thirdly is the handling of concrete mix. Once the concrete is mixed, the concrete has to be handled properly and is to be poured on the site. Sometimes poor handling of concrete while pouring also lead to segregation. Make sure the concrete is transferred directly from the skip or bucket to the final position in the form. Lastly is the placing of the concrete mix. It is observed that best construction practice follow the replacing of concrete. Usually, concrete always segregate if it falls from height more than 1 meter at the place of casting. When concrete falls from more than 1 meter, the large aggregate separate from the mixture will result in segregation of concrete. And how to do reduce segregation in concrete? Firstly, we need to use water cement ratio should be in limit of concrete. Then the concrete should not be too wet and too dry. Then never place concrete from large height. And concrete transportation must be correctly to choose the shortest road. And the formwork should be tight. Do not vibrate the formwork, and the vibrator should be used in concrete for right time and make sure it is not too long or too less. Thank you.
Less.
Assalamualaikum. So I will continue with the scaling. So for those who wonder what scaling looks like, so that is a photo we show here. Scaling is one of the most common problems of concrete. In scaling, the surface layer of concrete gets deteriorated by getting peeled or by breaking off. Essentially, water in concrete creates an expansive pressure due to repeated freezing and thawing cycles and leads to the breakaway of near surface concrete. These same chemicals exacerbate the expansive water pressure as it increases the concrete saturation and freezing the and thawing cycles. In moderate cases, the depth of patches range from 2.5 to 10 mm. However, it leads to aggregate exposure and popping out of aggregates in severe cases. Causes of concrete scaling is 1. Exposure of concrete to freezing and thawing cycles before the concrete gains the required strength. Second is use of low strength concrete or high water cement ratio, which facilitates deeper penetration of water in solutions. Next is the use of non-air entrain or too little entrain air leads to poor air void system in hardened concrete. And then curing concrete for a shorter period than required leads to the increase in concrete permeability, reduction of concrete strength and durability, and then an improper curing regime. Other than that is lack of adequate concrete protection after each placement. Improper finishing may trap water in concrete surface and subsequently reduce concrete strength. And then quick drying of concrete surface prevents the concrete surface from achieving the designated strength. As a result, the risk of scaling increase. The use of desing chemicals for new concrete increase the likelihood of scaling. And then the ways to prevent scaling in concrete. First is using air train concrete. Second, not performing finishing steps till the water is present on the surface. And then you can not using desing salts such as calcium, magnesium, or sodium chloride. And then properly curing the concrete with the use of liquid membrane curing compound by covering the surface of freshly placed slab with wet burlap and polythene sheets or a non-woven geotextile. And lastly is protecting the concrete surface during harsh weather conditions. Next is cracking. This is the photo of cracking. So concrete fractures can be either structural or superficial fissures. Surface cracks are usually only a few millimeters in width and depth. Hairline cracks are single, tiny cracks or fissures in a crease map-like pattern that are commonly referred to as hairline cracks. A few surface or shrinkage cracks are common and normally do not create any difficulties. Freeze-thaw cycles, poor construction practice, and alkali aggregate reactivity can all create surface fissures. Surface fractures can form when new concrete is poured over existing concrete because new concrete shrinks as it dries. This happens. Surface cracks in the spillway should be checked and fixed if they continue to deteriorate. So this is the causes of concrete cracking. First is excess water in the mix. On the job site, a lot of the concrete used in the residential post has too much water added to it. This water is injected to make the concrete installation process easier. The excess water, on the other hand, will drastically diminish the concrete's strength. Another typical cause of cracking is shrinkage. Concrete shrinks as it hardens and dries. The evaporation of extra missing water is to blame for this. The higher the shrinkage, the wetter or soupier the concrete mix. And second is concrete drying too fast. Additionally, rapid drying of the slab will greatly increase the likelihood of cracking. Water is required for the chemical reaction that transforms concrete from a liquid to plastic. This chemical reaction, known as hydration, continues for days or weeks after the concrete is poured. And three is improper strength concrete pour on the job. Next. And four, lack of control joints. In the concrete slab, control joints help concrete cracks where you want it to. Sorry. The joints should be of the depth of the slab and no more than 2-3 times of the thickness of the concrete. So for concrete, should have joints 8 to 12 apart. And 5 is foundations poor in the winter. Foundations poor during cold months or poor. Not yet. Okay. Poor foundation that are left unheated during the cold winter months will develop many more cracks. Foundations poor on a base that is improperly compacted will inevitably develop more cracks as well. So next I will give the next presenter to present.
Hello, Assalamualaikum. My name is Haziq, and now I will present the way to prevent cracking in concrete. First, we need to maximize the cost aggregate in concrete mix. Admixture containing calcium chloride must be avoided. Number 2, we also need to use low water cement ratio. Concrete does not require much water to achieve maximum strength, but a wide majority of concrete used in residential work has too much water added to the concrete on the job site. This water is added to make the concrete easier to install. This excess water also greatly reduces the strength of the concrete. And number 3 is patch the concrete using concrete filler or caulk. Wide cracks in the concrete are best patched and sealed with a concrete patching compound. Smaller cracks, less than 1/4 inch wide, can be repaired with a concrete caulk or liquid filler. Patching compound typically are mixed with water and applied with a trowel. They have a texture similar to grout and can be smooth and texture to blend with the surrounding area. And number 4, we need to use a penetrating concrete sealer to prohibit any water penetration, which will maximize freeze-thaw damage. Next is the disintegration. Disintegration is the act or process of disintegrating or the state of being disintegrated. The breakdown of concrete into microscopic fragments and individual particles is known as disintegration. The surface mortar flakes off in a granular form of disintegration called scaling. Serious concrete deterioration is indicated by large section of crumbling, rotten concrete. Deterioration that is more than 3 to 4 inch deep, depending on the wall or slab thickness, and exposed rebar. This sort of concrete deterioration is not addressed, can lead to structural instability of concrete structure. The next, this is the cause of concrete disintegration. There is 5 causes. First is a sulfate attack. Number 2, alkali aggregate reaction. Number 3 is carbonation. 4th, chloride attack. And 5th is acid attack. So next is the next presenter.
Okay, thank you. Lastly, the ways is to prevent disintegration concrete. Firstly, is to avoid use of alkali reactive aggregate. Secondly, is to use cement with a low alkali content. And lastly, use of pozzolanic material which prevent alkali aggregate reaction but is combining with the alkali present in cement. I think that's all from me and our group. Thank you.